This is section 5.6, rational functions. This information is associated with the free OpenStax textbook, College Algebra. I have the information or the link for that in this presentation, so you can see it throughout. So if you want more information, you can reference that free textbook for that. So these are some examples that come from the textbook that we're going to go over. So the first thing we're going to look at is these examples of rational functions, and we're going to talk about how to pick out pieces of information from the function, and then this is just building up toward graphing these. So in this first one, we want to find the domain, the vertical asymptotes, the horizontal asymptote, and then the x and y intercepts. So first of all, remember for the domain, if you have a fraction, the denominator cannot be 0. So to find the domain, what you're going to do is you're going to take the denominator and set it equal to 0 and see what problems that we'll have. So to solve, we're simply going to subtract 2 from both sides, and we'll get 5x equals negative 2. And then we divide by 5, so we see that x is negative 2/5. So when x is negative 2/5, that makes the bottom 0, which is not allowed. So we're going to eliminate that from the domain. So x cannot be negative 2/5. We can either say it like that, or if you need to write it in interval notation, you would write negative infinity to negative 2/5. And you're using a parentheses around the negative 2/5 because you don't want it to be that. Union negative 2/5 to infinity. So there's our domain. It can be everything except negative 2/5. Now to find our vertical asymptotes and our horizontal asymptotes. So when you're finding asymptotes, an asymptote, when you have a graph, an asymptote is kind of a imaginary line that the graph almost never crosses. Sometimes it does. So you might have asymptotes that look like that. You could have a vertical asymptote. You could have a horizontal asymptote. So this is the vertical asymptote, and this is the horizontal asymptote. Remember that a vertical line has an equation, x equals some number, and the horizontal line has an equation, y equals some number. So your asymptotes will have an equation associated with them. There's also something called a slant asymptote, and a slant asymptote is an asymptote that has a slant to it. Okay, the slant asymptote will be y equals mx plus b form. Okay, so it'll have some kind of slant, which is why it's in that form, because it has a slope. So those are the different asymptotes that we'll be talking about. And you can find them from the equation given from the function. Okay, so the vertical asymptote, okay? So the vertical asymptote is always going to come from the denominator. So the denominator, just like we found the domain, whatever that is, that's your vertical asymptote. So for example, this equation without the slash through the x equals negative 2/5, that's your vertical asymptote. That's a line that the graph will not cross, and the reason it doesn't cross that is because x cannot be that value. So on your graph, if you have your graph, let's say here, okay, and our vertical asymptote is x equals negative 2/5, which would be somewhere right over here. This green line, the graph cannot cross the green line. So your graph might look something like, let's do the graph in, I don't know, red. The graph might look something like this. Okay, so it approaches the green line, but it never crosses the green line, and that's because x cannot be negative 2/5, which is what we found in the domain. So your vertical asymptote is an imaginary line that your graph cannot cross because x cannot be that value. So that's what your vertical asymptotes are, and that's why they're associated with the denominator. So to find your vertical asymptotes, you do that the same way you find the domain. You're looking at the denominator and finding out when that will be 0. Okay, so now we're talking about the horizontal asymptote. So to have a horizontal asymptote, you have two cases. Case 1, let me see, I need to scroll up so I can give you some information here. So horizontal asymptotes. Okay, so case 1 is the degree of the numerator is smaller than the degree of the denominator. So that means, remember, the degree is the highest exponent. So the highest exponent in the numerator is smaller than the highest exponent in the denominator. An example might be if you have f of x equals 3x over x squared plus 2. See how the degree here is 1 and the degree here is 2? So the numerator's degree is smaller than the degree of the denominator. In that case, your horizontal asymptote will be y equals 0. Whenever the degree of the top is smaller than the degree of the bottom, your horizontal asymptote is automatically y equals 0. Your second case is the degrees of the numerator and denominator. Numerator and denominator are equal. Okay, so an example of that would be 3x squared over 4x squared. In that case, you're going to look at the coefficients of your highest degree. So the coefficients would be 3/4. That would be your horizontal asymptote. So your horizontal asymptote, if the degrees are the same, you just look at the coefficients of the highest degree, and then that would be your horizontal asymptote. If the degree of the denominator is smaller than the degree of the numerator, that's when you have a slant asymptote. Okay, so I guess I can go ahead and write that up here now as well. So a slant asymptote. So that is when the degree of the numerator is larger than the degree of the denominator. When you have something like that, you're going to have to do synthetic division to find your slant asymptote. So let's say you have f of x equals 3x squared minus 2 over 4x. Here you can see that the degree of the top is bigger than the degree of the bottom. So at this point, you would do synthetic division and you would find your slant asymptote. Okay? So, and we'll do an example like these in just a minute, but that's going to give you kind of how to do these or how to find these. Whoops. All right, let me erase this. Okay, so we're still on number 1. So we want to find the horizontal asymptote. So in this case, we're looking at the degree. So the degree of the top is 0 because there is no exponent, and the degree of the bottom is 1 because it's x to the first. So the horizontal asymptote is y equals 0. And that's because the degree of the top is smaller than the degree of the bottom. All right, x and y intercepts. So now we're going to find those. So the x-intercept, we're going to let y be 0. Remember, y is f of x. The only time, so we're saying this fraction is 0. Okay, the only time a fraction is 0 is if the numerator is 0. So when you're finding the x-intercepts, all you're really looking at is when is the numerator 0. So you can ignore the denominator. So you want to look at this. Well, is 0 ever equal to 2? No. So there is no x-intercept. Okay? So just set 0 equal to the numerator and solve that to find the x-intercepts. The y-intercept, you're going to let x be 0. So we'll have y equals 2 over 5 times 0 plus 2. Well, that's going to be 2 over 2, which is 1. So your y-intercept is going to be 0, 1. And now we found all the pieces that we need. Okay, so number 2. Okay, so first, let's find the horizontal asymptote. So the horizontal asymptote you find by just looking at it and looking at the degree. So the degree of the top is 1. The degree of the bottom is 2. So the degree of the top is 1. The degree of the bottom is 2. Since the degree of the top is smaller than the bottom, we will just have y equals 0. To find our vertical asymptote, we are going to figure out what makes the bottom 0. So the work for that is x squared plus 5x minus 36. So we're going to have to figure out what makes that 0. So we can factor that into x plus 9, x minus 4, because 9 times negative 4 is negative 36, and 9 minus 4 is 5. So then I have x plus 9 equals 0, which means x equals negative 9. And x minus 4 equals 0. When we add 4 to both sides, we get x is 4. So those are our two vertical asymptotes. X equals negative 9. And x equals 4. Okay? Now remember that this work that we just did is to find the vertical asymptotes, but it also helps define our domain, which we're asked to state here. So our domain is everything except those numbers. Remember, the bottom cannot be 0. So for the domain, we're going to say x is everything except negative 9 and 4. And if you have to write it in interval notation, you're simply going to write negative infinity to the smallest value, then the smallest value to the second smallest value. Okay, and you're just leaving out those values that you don't want. And so the negative 9 and the 4. So there's our domain. All right, and now we need to find our x-intercepts and our y-intercepts. So to find our x-intercepts, we're going to let y be 0. We're just looking at the numerator. So we're going to have 0 equals x. Well, there we go. That's our x-intercept. 0, 0. For the y-intercept, we're going to let x be 0. So we're going to have y equals 0 over 0 squared plus 5 times 0 minus 36. So it's going to be 0 over negative 36, which is just 0. So again, we have an intercept of 0, 0. So the next problem, number 3, we're going to do the same thing. So the first thing we want to do is look for the horizontal asymptote. So the horizontal asymptote, I'm looking at the degree. So the degree of the top is 1, the degree of the bottom is 1. So since they match, I'm going to have to divide the coefficients. So the coefficients are 2, -2, and 3. So that means the horizontal asymptote is going to be y equals -2/3. Okay, now the vertical asymptote, we're going to find that by setting the bottom equal to 0. So 3x minus 1 equals 0. So that means 3x equals +1 because we add 1 to both sides. We divide by 3, so we get x equals 1/3. So x equals 1/3 is the vertical asymptote. Remember that that is associated with the domain. So this means that x can be everything except 1/3. So the domain is going to be -infinity to 1/3 union 1/3 to infinity. Okay, so there is the domain. Okay. And now we want to find the x-intercepts and the y-intercept. So x-intercept, remember we let y be 0. And remember that means you're just looking at the numerator. So 4 minus 2x is equal to 0. So if we add 2x to both sides, we get 4 equals 2x. Divide by 2, we get x equals 2. Okay, so we have 2, 0 as our x-intercept. And then the y-intercept, we're going to let x be 0. So we're going to have y equals 4 minus 2 times 0, 3 times 0 minus 1. So we're going to have 4 over -1, which is -4. So 0, -4 is the y-intercept. Okay, so now we found all the pieces for that one. All right, number 4, find the slant asymptote. So keep in mind that it won't necessarily say that you're going to have a slant asymptote when you do. It could just say find the asymptote, and you'll have to recognize that it has a slant asymptote. And so the way you recognize that is you look at the degree. The degree of the top is 2, and the degree of the bottom is 1. So since the degree of the numerator is larger than the degree of the denominator, that's what tells you you're going to have a slant asymptote. That means you do not have a horizontal asymptote. So you either have a slant or a horizontal, not both. Now you can still have vertical asymptotes, but horizontal and slant asymptotes, it's one or the other. So you're going to have a slant asymptote, and the way you're going to find that is you're going to either do long division or you're going to do synthetic division. So either one is about the same amount of work. If you want to do synthetic division, remember that you're going to be dividing by the bottom, and your numerator, your coefficient of the x has to be 1. So in order for the coefficient to be 1, I need to divide by 2, which is going to give me x minus 2. And then I use this for synthetic division. So if it's x minus 2, that's the factor. That means I'm going to be using a +2 to divide by. So 2. And then in the numerator, I have 4x squared minus 10. We're missing the x piece, so I'm going to add in a 0 placeholder. So that'll be 4, 0, -10. Bring down the 4, we multiply and get 8, we add and get 8. We multiply 2 times 8 and get 16. We add straight down and get +6. When you're using this to find the slant asymptote, you just kind of ignore the remainder and you use the first part for your slant asymptote. So this would be y equals 4x plus 8. That will be your slant asymptote. Oh, one other thing. I forgot. What did I forget to do here? So remember in the beginning, I divided by 2. I have to adjust my answer as well. So I need to divide both of these pieces by 2. So I will get y equals 2x plus 4. That is my slant asymptote. So remember, that's one thing about using long division, is that you don't have to remember to adjust in the end. So if you use synthetic division and you make that adjustment in the beginning, you have to remember to make that adjustment in the end, or you're going to get your answer wrong. If you do long division, you don't have to make the adjustment. You just divide and you get your answer. So just keep that in mind. All right, number 5. We have find the horizontal intercepts, the vertical intercept, the vertical asymptotes, and the horizontal or slant asymptote of the functions. Use that information to sketch a graph. Okay, so I'm basically finding all the pieces I just found for the others, and then I'm going to graph it on top of that, okay? So first, let's find if it has a horizontal or slant asymptote. So when I'm looking for that, the degree of the top is 0, the degree of the bottom is 2, so it means I'm going to have a horizontal asymptote. And since the degree of the top is smaller, it's automatically y equals 0. So I'm going to go ahead and draw in green. That's going to be my horizontal asymptote. Okay, so that's in green. All right, now let's find the vertical asymptote. So remember, to find the vertical asymptote, you need to set the bottom equal to 0 and solve. And you just have to set the factor equal to 0. You don't have to do the square. If you do, you're just going to end up doing an extra step, but that's okay. So x equals 2, since I add 2 to both sides, is my vertical asymptote. All right, so that one I'm going to do in red. Okay. So x equals 2 will be here. All right, so those are my asymptotes. I've got my horizontal and my vertical asymptotes. Okay, so now I want to find my intercepts. So I want to figure out where this crosses the x and y axis, or if it does. So to find the x-intercepts, we're going to let y equal 0. Remember that the fraction can only be 0 if the numerator is 0. So really we're just looking at the numerator set equal to 0. Well, 4 equals 0 does not lead to a solution. So this means there are no x-intercepts. And y-intercept, we let x be 0. Okay, so that means we're going to have y equals 4 over 0 minus 2 squared. That's going to be 4 over, that's negative 2 squared is 4. So it's going to be 1. So 0, 1 is my y-intercept. So 0, 1 is my y-intercept. I'm going to put that here. Okay, so now I know it crosses there. Now, remember when we talked about our toolkit functions back a couple chapters ago, we had 2 different toolkit functions dealing with these rational functions. We had 1 over x, okay, and that toolkit function looked like this, okay. So that looked like that. And then we also had 1 over x squared. And that toolkit function looked like this. Okay, so the 1 over x squared in the middle, they were both approaching this vertical axis, both of them, right? Going toward that. So they're both going the same direction, going toward the vertical asymptote. They're both going up as you approach the vertical asymptote. On 1 over x, this side is going up as you approach the vertical asymptote, but this side is going down. So they're going in opposite directions as you approach the vertical asymptote. This 1 over x is like a 1 over x to the first. So this is going to be associated with odd powers. Okay, and this is going to be associated with even powers. So we need to look at that for number 5. So for number 5, notice that we have an even power here. So it's going to resemble the toolkit function of 1 over x squared, right? So they both have to be going up or in the same direction. So I have this 0, 1 as my y-intercept. Since I know there's no x-intercept, I know it doesn't cross the green. That means it's got to be going up like this. And this has got to be going down like this. Okay? And since I have a square, I know that on the asymptote, the vertical asymptote, they both have to be going the same direction. So since the left side is going up, the right side has to be going up toward the red as well. And again, it doesn't cross the green, so that would be a good sketch of the graph. Okay. So let's look at another one. So this is really bringing together information from a lot of different things that we've done. So in this one, number 6, we're going to be doing the same thing. So we want to first decide if it has a horizontal or slant asymptote. So we're going to do that by looking at the degree. So the highest degree on the top is 2 and 2 on the bottom as well. That means it's going to have a horizontal asymptote. Okay, but in this case, you have to divide the coefficients. Okay, so that would be 3 divided by 3 is 1. So y equals 1 would be our horizontal asymptote for this one. Okay, now the vertical asymptote, and let's go ahead and do that on the graph over here. So horizontal asymptote, y equals 1 is there. Okay. All right, so now we're going to find the vertical asymptote. Remember, that means we're going to set the bottom equal to 0 and solve. So that would be 3x squared plus 8x minus 16. So we need to factor this out. So we're going to have 3x squared. We need to figure out what multiplies to get negative 48. So 3 times negative 16 is negative 48. And adds to get 8. And then we're going to do the factor by grouping method. So that would actually be positive 12 and negative 4. Okay, so we are splitting this into these two terms. And if you don't remember how to do this, you probably need to go rewatch the video on factoring. And now we're going to factor by grouping. So we have 3x and then x plus 4. Bring down the negative. Factor out a 4 that's in common. So if I'm dividing out a negative 4, I get x plus 4 again. Remember that you should get the same factor when you're doing factor by grouping in parentheses. So then you have x plus 4 and 3x minus 4. Okay, so now I can set each of those equal to 0 separately and solve. That means x equals negative 4. And then 3x minus 4, 3x equals 4. So x equals 4/3. So those are my two vertical asymptotes. So x equals negative 4 and x equals 4/3. Now remember, when you're writing an asymptote, you have to write it as an equation or it won't be considered correct. It's not just a number, it's an equation. All right, so my vertical asymptotes, x equals negative 4 and x equals 4/3, which is a little more than 1. So there are my asymptotes. Okay, so now I need to figure out where my graph crosses the x and y axis. So I'm going to do that. So to find my x-intercepts, I need to let y be 0. Okay, that means I'm just looking at the numerator. So that's 3x squared minus 14x minus 5 equals 0. So again, I'm factoring. So this is going to be 3x squared minus 15x plus x minus 5 equals 0. So I split this negative 14 up into negative 15 and positive 1. So then I'm going to have a common factor of 3x in the first pair. So that'll leave me x minus 5. Bring down the plus. That'll be x minus 5. So x minus 5 and 3x plus 1 are my two factors. Okay, and so that means x minus 5 equals 0, so x equals 5. 3x plus 1 equals 0, so 3x equals negative 1, which means x equals negative 1/3. So the x-intercepts are 5, 0, and negative 1/3, 0. So that's where it crosses the x-axis. All right, so 5, 0, and negative 1/3, 0. So somewhere right around there. Okay. Now our last step is to find the y-intercept. So let x equal 0. Okay, so if I'm letting x be 0, I'm going to have y equals, everything that has an x in it is going to cancel out, right? Because it's going to be 0. So that's going to be negative 5 over negative 16 is all that will be left, because everything else will be zeros. So that's just going to be 5/16. So 0, 5/16 is our y-intercept. So that is like somewhere right there. Okay, so now we have all the little pieces on the graph. Now it's a matter of connecting everything and drawing our curves, our continuous lines, right? So the first thing to notice, let's rewrite this in factored form. So we factored out the numerator and got x minus 5 and 3x plus 1. We factored out the denominator and got, what, x plus 4 and 3x minus 4. Okay, so notice that we don't have any powers on any of our factors. So that's going to make a difference, okay? So we have no powers on any of the factors. So on the vertical asymptotes, we're looking at each vertical asymptote. Notice that there is no power, right, on either of the asymptotes. That means as each piece approaches the asymptote, it's going to be going in an opposite direction from the other side. So for example, this side, I can see from these two dots right here that they have to be connected, and they're going to go up like that. Okay, because it only makes sense if those two have to be connected because they're within that blue piece. So the vertical asymptotes are splitting the graph up into pieces. Okay, so everything between the two blue lines has to be a nice connected line. Okay, a continuous curve. So these two dots have to be connected. So it makes sense that they're connected like that. The other thing you want to look at is how your graph crosses the x-axis. So that is what we talked about before in a previous section about multiplicities. And so notice that each of the exponents here are 1s. So that means that it's going to go straight through the x-axis. So that means I can continue with that curve just straight through the x-axis. Okay, it's not going to bounce back up. Now I can use that information to do the rest of the graph. So since this side is going up, right, on the other side of this blue line, it needs to be going down because there's not a power on either of the asymptotes, the factors in the denominator. Likewise, as I go down, right, on this side, that means on the other side of this blue line, it needs to be going up. So I'm going to be drawing it up like that. Okay. So something like that would be an appropriate sketch. All right. Now we're going to be, and here's the information for the textbook, by the way, if you want to pause and get that. Now we're going to write an equation given the characteristics of the graph. So we're going to try to write the equation now. Here is the key to this. Remember that the denominator is associated with the vertical asymptotes. So the vertical asymptotes, okay, that's going to be telling you about the denominator. Okay, and then the x-intercepts are associated with the numerator. So the vertical asymptotes, that's going to be telling you your factors in the bottom. Your x-intercepts, that's going to be telling you your factors in the top. And then the other point that they're giving you is going to be to find the multiple that you're multiplying your function by. Okay, so first of all, when you're writing these, you're going to write f of x equals, you're going to write some multiple a, and then you're going to write your factors. So your numerator is going to be x minus 2. So this positive 2, remember your factor is the opposite sign. So x minus 2 is going to be given from that. This negative 1, the opposite sign of that is positive 1. So that'll give us a factor of x plus 1. So that goes in the numerator. All right, now in the denominator, it's the same thing. The denominator, we have an x equals 5, and so that will be associated with a factor of x minus 5. And then the negative 5 would be associated with the factor of x plus 5. So remember to always change your signs from those. Now what you have to do is you're going to use the y-intercept, this other point, to figure out your a. So this gives you an x value and a y value, and you're going to plug that in and figure it out. So y is 4 equals a times x is 0. So 0 minus 2, 0 plus 1, 0 minus 5, 0 plus 5. Okay, so to me it's easiest to write it like this. 4 could be 4 over 1. So 4 over 1 equals negative 2 times 1. So this is negative 2. This is 1. That's going to be negative 2. Put the a in the top. Okay. Negative 5 times 5 is negative 25. When you write it like this, you just have a proportion. So you can just cross multiply. So you'll have negative 25 times 4 is negative 100. 1 times negative 2a is negative 2a. You're going to divide by negative 2. And so then you'll get a equals 50. Okay, so now you're going to use this 50 and plug it in here. Everything else will be the same. So you're going to have f of x equals 50 times x minus 2, x plus 1 over x minus 5, x plus 5. Okay. And that would be your function. Okay. So that's the same thing you do every time. That's the pieces of information you're looking for, and that's how you work it out. So on this one, we have the vertical asymptotes, we have the zeros, and we have the y-intercept. So same thing, we're going to have f of x equals some factor a. Remember the vertical asymptotes, that's related to the denominator. So x equals negative 1, so that'll be x plus 1. And then we have the 0, so that's going to be in the numerator. And since it says it's a double 0, that means it's going to be squared. So x minus 2 squared. And then we're going to use our y-intercept to find the a. So we have an x value and a y value. So y2 equals a times 0 minus 2 squared over 0 plus 1. Okay, so we're going to have 2 over 1 equals negative 2 squared is 4, so 4a over 0 plus 1 is 1. We cross multiply. So we get 2 equals 4a, divide by 4. So a equals 1/2. All right, so we're just going to rewrite our function that we wrote with the 1/2 in the place of a. So 1/2 times x minus 2 squared over x plus 1. And there it is. Okay, so now we're going to do the same thing with graphs. So I know it's a little blurry, I apologize, but I wanted to get it large enough to where you could see easily the parts. So this is the same thing we just did. It's just now we have to pull the information out from the graph. So you want to look for the vertical asymptotes. So your vertical asymptotes are x equals -3. Right? So that's this one, x equals -3. And then the second one is x equals 4. Okay? So we look for the vertical asymptote, and then we look for the x-intercepts. So the x-intercept here is right here. So it looks like it's probably 3. So 3, 0. Okay? And so that will give us the parts that we need for our fraction. Now, the other thing we need to do is look for exponents. On the x-intercept, it looks like this is just going straight through the x-axis. So that will be a power of 1. Then we want to look at how the behavior is on the graph. So notice that this is going up and this is going down. So since those are going in opposite directions, that will be a power of 1. And then the same with this first asymptote. This side is going up, this side is going down, so that will be a power of 1. So we're going to have f of x equals a. The numerator is going to be x minus 3 from the x-intercept. And the vertical asymptotes are going to give us our denominator, so x plus 3, x minus 4. Okay, and then we're going to find another point on the graph in order to figure out a. So I would always try to look for the y-intercept if you can, so that would be here. So 0, 1. So 1 equals a times 0 minus 3 is -3. 0 plus 3 is 3. 0 minus 4 is -4. So this is going to be 1 over 1, -3a over -12. Cross multiply. So now we have -12 is equal to -3a, divide by -3, and we get a equals -4. Not -4. Should be +4, right? The two negatives cross out. All right, so a equals +4. Okay, so now we have f of x equals 4 times x minus 3 over x plus 3, x minus 4. Okay. Now we want to look at the next one, and this is the last one for this section. So same thing. We want to look for the vertical asymptotes. So here the vertical asymptote is x equals -3. And here the asymptote is x equals 2. We want to look at how it's behaving around the asymptote. So if you look at the x is -3, on the left side of the asymptote it's going up. But on the right side of the asymptote it's going down. So that's associated with a power of 1. For the x equals 2 asymptote, notice that on the left side of the asymptote it's going down, but on the right side of the asymptote it's also going down. So this is going to be associated with an exponent of 2. So we're going to have f of x equals a. Remember the asymptotes, these vertical asymptotes give you the denominator. So x plus 3 and then x minus 2 squared. Okay, so now to find the numerator, we're going to be looking for the x-intercepts. So if I'm looking for the x-intercept, I notice that it crosses right here. So right here, and that looks like it's probably at 1. So that would be the point 1, 0. That would be the x-intercept. And notice what happens when it gets there. It bounces, right? It's going up, and then it gets to that point, it bounces back. Remember that that's associated with a multiplicity of 2. So our numerator is going to have x minus 1 as the factor, but with an exponent of 2 because of that bounce. Okay, so now that we have that, we're going to find another point in order to solve for a. And so our other point, I'm looking at the y-intercept. It looks like it crosses the y-axis right here. So that looks like negative 1/2. So that will be the y value. So we will have negative 1/2 is equal to a times 0 times so we're plugging in 0 for x. So negative 1 squared will be 1. Then 0 plus 3 is 3. 0 minus 2 is negative 2. Squared is 4. So this is going to be negative 1/2 is equal to a over 12. And again, you're going to cross multiply and solve. So you'll have the negative can go with either one. So let's put the negative up here. So we negative 12 is equal to 2a. Divide by 2, you get a equals negative 6. So now you're going to put the negative 6 in for the a. So you're going to have f of x equals negative 6 times x minus 1 squared over x plus 3 times x minus 2 squared. And that will be your function.